welcome to the Unit 10 probability review video. And in this video, we're going to just kind of review some of the main differences between calculating theoretical probability and experimental probability, and then how to just kind of compare the two. Now, first thing I want to point out was that the theoretical probability is a lot like your hypothesis in science. It's what you think is going to happen. And then the experimental probability are the results, what actually did happen, okay? So for the first question, we're going to look here that says the chart shows the theoretical probability of selecting cookies from a bag. So the theoretical probability of chocolate chip is half, oatmeal is 3/8, and then sugar is 1/8. Basically what we're saying is that in a bag of cookies, okay, half the bag is chocolate chip, 3/8 are oatmeal, and 1/8 are sugar. And I can even show you guys briefly like a little pie chart. This is something that we've kind of covered towards the end of the school year, and I think that you guys are a little bit better at how these would operate. So we're basically saying then again that half is chocolate chip. I'm just going to put a CC for chocolate chip. We also can know that like that half is 4 of the 8s. And so then basically I can say, okay, here's 1, 2, 3. These are my other 1, 2, 3, 4. So 3 of my 8s right here, let me trace it in red. That's oatmeal. Okay, I'll just put an O for oatmeal. And then 1 of the 8s, just one of my little slices right here, would be the sugar cookie. Okay? So we've got chocolate chip is 4 of the 8s, half. Oatmeal is 3 of the 8s. And then the sugar cookie right here is just my one little slice of the pie, 1/8. So which cookie has the best chance of being selected if we're going to randomly be selecting a cookie from the bag here? Well, the chocolate chip, just because they take up 50% of the bag. Okay, and we're using theoretical probability to make that prediction. And then which cookie has a theoretical probability of 12.5% of being selected at random? Well, let's see how good you guys are with converting. You might remember that obviously 12, 1/2 is 50%. And with the 8s, the 3/8 would be 37.5%. And 1/8 would convert to 12.5%. You just do 1 divided by 8. And so that's 12.5. So really, this question is kind of a unit 1 question, checking to see if you can convert a fraction to a percent. But for this one, we get sugar cookie. Okay? So then it looks like 20 students randomly selected cookies from a bag, which is kind of nice. It's like, all right, cool, you get a free cookie, but you don't know which one you're going to get. You just got to pick randomly, and you'll get one of these types of cookies. So these are the results now, and it asks first, according to the results, which cookie has a 40% chance of being selected. Now again, according to the results, 40%. So first what we care about is actually the total here, which we again already know is 20 students, so we can just add these up and that'd be a 20. And so chocolate chip was 9 out of 20. Oops, there's a 20. We had an 8 out of 20 or a 3 out of the 20. Now, some of you might remember when we talked about our proportional reasoning that if you're trying to make it a percent out of 100, you can just look at the denominator. And here, this would be a times 5. So if we just do times 5, we'll get the percentages. So this is going to be a 15% for sugar cookie. 8 out of 20, so 8 times 5 would be a 40%. And then 9 times 5 would be 45%. All right, and these would add up to 100% of the time. So it asks which cookie has a 40% chance of being selected, and that was the oatmeal cookie with 8 out of 20. If you didn't like my proportional math down here, you could just do 8 divided by 20, which is 0.4. And again, you guys can see then that that'd be a 40%. So we got oatmeal for this one. Now the next section is just a series of true or falses. So let's see. Let me just erase this math real quick. All right, the theoretical probability of selecting an oatmeal cookie, which is up here, is that greater than what happened, the results down here, of selecting a chocolate chip cookie, which was right here. Now we just said a second ago that the 9 out of 20, those results was 45% of the time. So the question is this 37.5, is it bigger than this number? No. So this would be false. All right, less chocolate chip cookies were selected than we would have predicted. Now up here, half the bag is chocolate chip. So if 20 students are going to be selecting randomly, we would assume that half the students would select a chocolate chip cookie. Now we can see here that there were less. The 45% is less than the half we would have predicted. So this is a true statement. All right, and now for the third one here, the theoretical probability, so again, thinking about what we would have predicted, is that greater than the results of picking a sugar cookie? So up here, what we thought what is going to happen was 12.5% of the time. And what did happen, the 3 out of the 20, you might remember, was 15%. So is this number up here, the theoretical, is it greater than this number down here? No, 15 is greater. So the results, we got sugar cookies more than we would have predicted. And therefore, this is a false statement, okay? The theoretical here would have been less than the experimental down here. All right, one more example here for the video. This problem should also look familiar because this was back in your probability packet. But Jessica asked her classmates what their favorite season is, and she recorded the results here. And first, let's tally up how many classmates she actually asked. She asked 2 that responded for winter, plus these 10 right here, that's 12. Now, these 15 who responded for summer, plus the 5 for fall, that looks like 20. So we can just say, okay, I've got these 20, 32. It looks like there were 32 total. Okay, 32 total. Which statement is true about spring? So we're going to focus only on spring, which is right here. And it looks like the results, we had that 10 out of the 32 selected spring. Let's go ahead and reduce this, 10 out of 32. This divided by 2, and then this divided by 2. So these are the results. This is the experimental probability, okay? Now the true false is going to ask us to compare experimental to theoretical. So theoretically, spring would have had a 1 out of 1, 2, 3, 4 chance. Spring theoretically would have just had a 1 out of 4 chance of being selected. Now what we need to do is just convert these real quick into percentages. So let's get the calculator out. And theoretically, I think you guys are okay with that being a 25%. That's not a problem, a fourth of the time. But let's just divide the 5 by 16 real quick to see what it is as a percent. All right, if I move that decimal over twice, it's going to be a 31.25%, a 31.25%. So it looks like the experimental results are greater than what we would have predicted. More people voted for spring than we would have predicted. All right, so now let's go through and let's try to find which one says that. Now, what we first care about is that the experimental should be the 5/16. Now, this says the theoretical is 5/16. So automatically, we're going to knock out A. Now, B does appropriately assign theoretical to 1/4, so that's still in the running. But look at answer choice C. It says the theoretical probability was the 5/16, so C is out of the running. D appropriately says that the theoretical probability is a 1/4, so that matches up. Both of these say that the experimental, oh, now look here, experimental, oh, we already, sorry, JK, we already knocked that one out. But this one did say experimental matched up here, and this one also matches up the experimental here. So now we just care between B and D, which one says it the right way. Is 25% greater than 31%? No. Is the theoretical 1/4, 25% less than the experimental 5/16? Yes. So this one here was answer choice D. And again, when you're trying to compare which one's greater than or less than, I highly recommend making them both percents. And it makes a question like this one go a lot more smoothly. All right, that concludes this video. Thank you for watching.